model, which we
Correct.
can finding the attraction and production. Can you please tell that name, only name, so I can research it?
So people have used neural networks. I've seen some neural network models looking at estimating trip um,
Okay.
uh, trips from based on production attractions. Yeah.
Okay, sir.
I can't give you the references on the top of my mind, but I remember reading them.
Mm.
Uh, and this was probably 2 years back.
Okay, sir.
So if you just look at machine learning approaches
Mm.
to trip distribution, I think there might be a review paper also.
Okay, sir. Okay, I go through it. Okay, thank you.
Perfect. So the next thing which I want to talk about is so there's a recent work which we have been doing, and I thought it might be interesting to just share that. It is not final, so please do not use, or this is none of this is um, what I would call uh, finalized. So there's a lot of, so this is not full. This is not something I would go to the government and say that this is what it is. But the whole purpose of me sharing this is going through how we are analyzing it and how we are trying to do economic impact assessment and evaluating each of them, right? So the first thing, you've all heard of the dedicated freight corridor in India for the railways. Hello.
Yes, sir, I heard about it.
Yeah. So the dedicated freight corridor was set up uh, by the Indian Railways to actually support faster, more reliable transport of the freight goods. So one of the things which the freight industry was finding on the railways was that a lot of it was getting stopped and was getting affected by passenger traffic, and it was affecting the reliability uh, uh, and the on time arrival of these trains. So the first question was, is it reliable or not? So the first thing you do is you end up doing a distribution. You look at the speed distribution of your trains on the DFC versus on the Indian Railways, right? So what you can find is, let's try to look at. So this is part of the diagnostics, right? So this is what we are just kind of talking about it. So this is part of the diagnostics. So what we find is that the average speeds on the DFC. So DFC is green. So average speeds on the DFC is higher, and it's close to around 32 kilometers per hour for 24-25. And this one, the average. So this is the mode, but the average is uh, around 18 because it's got a heavy tail also, 15 to 18 kilometers per hour. This is what we find, and the standard deviation is also very large. Okay, so here it is much tighter. This one has a heavier tail. Can look, it's got a heavier tail. It's skewed to the left and got a heavier tail, as opposed to this, which is nice and symmetric and is much more tighter. And what we then looked at was, are there differences between the EDFC, which is the Eastern Dedicated Freight Corridor, and the Western Dedicated Freight Corridor? And what we find is that uh, the EDFC is ADFC and WDFC have very similar profiles. So a dedicated freight corridor is a dedicated freight corridor and has good performance from a speed and distribution standpoint. Then what we did was we looked at the coefficient of variance. So what is a coefficient of variance? Basically, it's standard deviation divided by mean speed. So what it's telling you is, given a mean speed, what is the standard deviation? So you want the mean speed to be high, but the standard deviation to be low, right? So what you want is generally your coefficient of variance to be going down, right? Standard deviation should be lower for the same mean speed. So again, if you look at DFC versus uh, IR, the coefficient of variation is quite low compared to IR. So what it's saying is that the standard deviation is also low, but the mean speeds are high, right? So that's why this is lower than the IR, the Indian Railways. So these are some of the statistics which you would generally try to evaluate and compare. Then we looked at developing a reliability index. So how do you do reliability? Now, one of the things you have is you have travel times. So usually you have travel time and then you have the standard deviation of travel time. Okay. But they are happening. So each trip has different travel length, right? So what you do is usually you do the calculations in pace, which is hours per kilometer. Does that make sense? So it's basically the inverse of speed. Any questions?
Sorry, sir, I have one request. Can you once more take up
Yeah.
actually my power? That's it.
Okay. So the concept of, so the first thing is when you're looking at reliability, you can look at reliability based on speeds, but what is generally useful is you're looking at reliability in terms of travel time. So what is your mean travel time and how, and what is the standard deviation of your travel time? Okay. But the thing about trips is there are different trips are experiencing different distances. Does that make sense? So there'll be some trips which are shorter, some trips which are larger. So how do you actually then evaluate this from a reliability perspective? So what we do look at is something called pace, which is actually the inverse of speed, which is what it's telling you is travel time per kilometer. So what is the number of hours to go per kilometer or number of minutes per kilometer? So what this distribution is showing is the number of hours per kilometer. So usually what you're finding is that the DFC has a lower hours per kilometer and is tighter. So the gray is the uh, the reliability. Sorry, DFC, and the red is IR, Indian Railways. Okay, so what we are doing is we are able to then say that the pace, which is the hours per kilometer, the is smaller for DFC, right? That's what you want. So that means it takes less amount of time to travel a kilometer, but also it is more reliable because the standard deviations are lower. And you can see that here. So in 24-25 on DFC, it took 0.038 hours per kilometer. And the standard deviation was only 0.028, right? So they're almost equal. And for IR, it was 0.132 is the pace, the hours per kilometer, and the standard deviation is 0.133. All right. So what you can from pace, and I'll explain to you why pace is important. Why can't we do this with speed? And I'll explain to you. Because like you have value of time in for travel time savings, you can actually have value of time for freight goods as well. And you have to be very systematic about how you're defining those value of time. And we'll talk about that in a moment. Any questions about this so far? The concept of pace. All clear?
Space is more or less about speed.
Yeah, it's the inverse of speed.
Okay. Okay.
All right. So one of the things we wanted to do then is look at cost savings. So I'll not go through the stakeholder interviews. Um, I'll go straight to the idea of working capital. Okay. What is working capital cost? The working capital cost is that if you take any raw material, right? Instead of that raw material actually being transported, if it's not being used, if the raw materials are not being used, right, then it is a waste. So let's say there is coal, but the coal is just sitting. It is a waste. So the point is, can we reduce the cost of working capital because that capital is just sitting, right? It is like I have money, but it's just sitting. I'm not getting it to be used in anything. So the idea of in economics is to have any capital you want it to be worked. You want it to go into the economy to work. and you wanted to go into work as quickly as possible. Okay. So the way you generally do working capital is there are two parts to it. One is the travel time savings, which is the fact that if you have reduced the travel time, then it has gotten to the production plant and it can be used faster, right? So that is the savings from the capital cost. So what you do is you look at the travel time between the travel time on what it would have taken on the Indian Railways minus the travel time on the DFC. So that tells you the travel time savings, right? Then I multiply that with the commodity value per unit, right? So let's say I'm using coal. So coal's value is uh, 10 rupees per ton, right? So that is the money. So that coal is almost 10 rupees per ton is just sitting. So that is the per unit cost of that commodity. And then you multiply that with the total units moved. So how many units was moved? So what was the total volume that was moved? So that gives you the total inventory, the total capital that is being moved, and the fact that the travel time has been saved. And R is the interest rate. So we generally assume 8.5% per annum. So that is you convert that. So per annum you convert that into per hour. It tells you what the interest rate is, and this is based on simple interest. So what is that? So what you're doing is you're trying to look at the fact that how much of that is being saved because of that travel time. Similarly, you can have that for capital cost savings for reliability as well, right? So that is basically sigma p IR minus b sigma p DFC multiplied by distance, because the if you remember, uh, uh, the distance is the trip distance. So because the standard deviation is the standard deviation of pace, so it is hours per kilometer. So I have to convert that into hours. So I multiply that with the distance, and then the rest remains the same. So what you end up having is you have a travel time savings and you have a reliability savings because of reliability. So why do you assume that you have reliability savings? What a lot of companies do, right? And we do that even at our home, right? Like uh, we hold on to rice. If we go into our kitchen, we have rice. We are holding on to that rice, and the reason a lot of time hold on to we have a stock of rice is because we don't know when we will go get time and go to the shops to pick up rice. Ideal would be if the rice was coming every day with reliability, but you're holding on to it. So similarly, power plants or anybody would try to hold on to it, hold on to a certain amount of it, just to make sure that there is a 95% confidence that the amount of raw materials they need will exist. So you generally take the 95th percentile of that standard deviation. So you multiply that with 1.64 to get, and that will give you the time. And that difference will give you how much is the savings from reliability perspective. So that comes out to be around 1,000 crores. So you have the travel time savings gives you around 112 million INR. And the savings gives you 902 from reliability. So the majority of your savings comes from reliability, all right, from a working capital cost perspective. And the final thing is, if you add both of them up, you get 1,000 million, which is, I think, 101 crores. 101 crores. Am I making sense? So this is just one one aspect of the economic cost savings for logistics. Any questions?
No, sir. Not.
Um, the next part, you have something called warehousing cost. So this is the working capital, right? So the fact that it was not being used, but then you're also storing it. So you're paying rent on the storage of that. So the storage cost, the warehousing cost is basically the you multiply the rent, the distance, and the volume with mu plus b sigma p. So that is mu is the amount of time it would actually be held in your held in the uh, held at a warehouse. So you're paying rent for that. And if I just look at the savings coming from rent, sorry, just give me 1 second. Just give me 1 second. Sincere apologies. So this is how we actually calculate the warehousing cost. Does this make sense? Hello?
Yes, sir.
Okay. Uh, right. So the second part is you also have an operational cost saving, right? The operational cost saving deals with um, how many less wagons you would need, right? If you were delivering things faster. So because things are you have to provide it at a certain rate. I'll try to explain to you. Give you an example. Let's say the average speed on a road is 10 kilometers an hour, right? And you want to keep an average headway of 5 minutes. So one of the underlying fundamental things is you want to keep an average um, um, average headway of 5 minutes. Now, if your average speeds were at 60 kilometers an hour, you would need less vehicles to be running at 5 minutes, as opposed to if the vehicles were running at 10 kilometers an hour. Am I making sense?
Yeah, yes.
Right?
So you are prioritized to freight vehicles compared to passenger.
So that is there. But what I'm trying to say is something more fundamental. Is what is this operational cost saving? So one of the big things which you're always going to experience is that people are going to try to, uh, and not people, but we have to be very, very careful about not double counting, right? So people will say, okay, you've already done this here in the working capital cost. Why are you including this in the warehousing cost? Because you have mu plus b sigma p here, and this is mu plus b sigma p here as well. Why? Why are you doing that? And the main reason for that, the main reason we have to look at it that way, is this one is basically associated to the rent, the warehousing cost of the rent. The rent the companies will save. This is the cost associated to the working capital, the fact that it was not being used. But then there is a third thing, is if your speeds are higher, you can actually maintain the same headways with a smaller fleet.
Yes, sir. Got it.
That's basically what it is, and that's where your operational cost savings are coming. So it is what you can actually do is, because you have so many GTKM per day, this is the number of wagons, but for the same amount, how many wagons would we need? And based on that, you can say that, all right, the wagons saved is around 55,000 wagons per day, which is roughly around 9,659 million INR, which is almost equal to 1,000 crores, 1,000 crores. So these are one of the few pieces of the puzzle of how we end up doing. And this is an actual project. We're doing an actual economic assessment of this, and it has taken us months to actually come to these decisions and agree on the methods for this. Any questions so far?
So that wagons you are mentioning, there are total number of wagons, right? We are not mentioning the how many railway trains we are required.
Yeah. It's the number of wagons. So I mean, usually um, you do your analysis, your operational cost savings per wagon, because that's what you pay for. So the
No, sir.
wagon cost is
Actually,
rupees 479 per day.
okay. Are you mentioning that we have maintaining this proper headway between the two rails?
So yeah, so
So,
that's because the speeds have increased, right? So because the speeds have increased, so
hmm,
let's say in IR we had 285.4 million GTKM per day
hmm,
on that stretch. So that
hmm,
needed 48,000 wagons. But because on the DFC it is faster, you might, this is the number of GTKM per wagon that is being charged. So you are actually getting a wagon efficiency because of that, because you're faster. So you can actually, because the speeds are faster, you don't need to run. Does that make sense what I'm saying?
yeah,
So you were only carrying 5,873 tons kilometer per wagon on the Indian railways, as opposed to 24,747, just because the speeds were larger.
yeah.
and you need a very fewer number of wagons
Yes, sir.
because of that.
Speed will increase, travel time will be always
Reduce.
decreases.
Exactly. Exactly. So, any questions so far on this? I wanted to actually talk through a little bit of the logistics costs as well, because all of what we have discussed have been around travel time savings, all of that. And but when we do a full CGE model, we will talk through all of this. So this is all, if you think about it, they're all small pieces of the puzzle. Now these puzzles actually all come together and affect each other. And we'll talk about that tomorrow. All right. Now what I want to do is shift gears into safety. Okay. So let me. And this was one of the questions you had about in the, I think it was in the very first class. How do you do economic assessment on roads for safety? Correct. Mm, so the first thing is, when we are actually doing any road safety study, there are two approaches we undertake. One is a before and after study. So we put an intervention. So we do a before study. Before we have the number of crashes for a certain period of time. We have that data, and then we do an intervention and see afterward what has been uh, the reduction in crashes. All right. So the problem is, to assess whether a crash countermeasure has worked or not, you need to estimate what would be expected to happen in the future if no action was taken. Right? So what do we mean by observational? What do we mean by experimental? And we will also talk about cross section. So observational can be before and after versus cross section. So what cross section means is that usually what you might also have is, let's say you're looking at interventions at an intersection, right? And whether or not they're working. So what you would do is you would look at similar intersections where in which with similar AADTs or whatever, and places where there is the intervention and places where there's no intervention. So if you're looking at a four-legged intersection with four-lane roads on in each of the approaches, you have another one with four-lane up this thing. And the only thing you have changed between those two is the amount of all red time. Okay. Am I making sense so far?
Yes, sir.
Yeah. So the only thing you're changing between the thing is the all red time. So because they are very similar intersections, the two intersections are very similar, you can evaluate. You can actually evaluate what the impacts are because of those two. Right? So experimental is more that you put in an intervention and see what's happening before and after. So now let's take this example. An agency plans next year to implement a crash countermeasure that will reduce crashes by 35% over the next 3 years. You need to estimate the benefit of this countermeasure. How would you go about doing that? Right? So this is giving you the crash data for the last 3 years. So I've taken an old 2008, 2009, 2010. Observed crashes was 30, 19, and 21. Right? This is the previous, the last 3 years. Now, if I had taken more, so if I take the average of this, that will be around, this will be 40 plus 37. Is that right? 70 by 3. That is around 23. Yeah, 23 point something. Now, if I take more data, it'll be less than 23 because you're also getting a few 17, 14, 9. So this will be 22 plus 23 is 45, 51, 61, 67, 77, 86, 100, 117, 117 plus 70 is 187. 187 divided by 10 is 18.7, right? So my average is 18.7, while before it was 23 point, 23 point something. So the difference in crashes is almost up to by 5. So there were almost a difference of 5 crashes per year. So one of the things about any data set is that there is a regression to mean. Like, so the more data you get before, there is going to be, you get a better this thing about to the mean. But also the other thing that is happening is maybe that the ADT is also increasing, right? So if there are more vehicles that are getting into, that are on the road, there's a higher likelihood of crashes. So even if the likelihood of crashes are the same, because the likelihood, the probability was the same, and there are more vehicles, you will observe more crashes, right? So let's say if the likelihood of a crash is 1% or 10%, and you had your ADT was 100 before, so you were expecting 10, but now your ADT has increased to 1000, so you'll observe 100, correct? Now you can't blame the countermeasure because of that. It has nothing to do with the countermeasure. It has to do with the fact that the ADT has increased. Yep. Am I making sense?
Yes, sir. Yes, sir.
Excellent. So this is just giving you the long-term average. That's around. This is a long. So this is just giving you an example. This is the long-term average, and you're moving between this thing, and then this is the 3-year average, and this is part of the random error. You can't take that as. So how do you accommodate for all of this? So what you should be looking for. So when we are looking at the true safety impact, we should not be looking at this 3 years before and 3 years after average. We should be looking at it compared to the true mean, the long-term mean versus the actual 3-year after average after, not the before. So there are statistical methods used for this, and one of them is called the negative binomial distribution and zero inflated, because you have a lot of data where you don't have crashes. So we'll talk about that. Any questions? Does this make sense, what I've talked about so far?
Sir, is there is any example so we can understand?
So this is the example I was kind of talking about, right? Like, so
Okay.
let's take this example only. We are getting on the long term average is around 3.5 crashes per year. Okay.
Okay, sir.
But if I take only a 3-year average, because of randomness, I'm getting around 5 crashes per year. Okay. In 2003, I apply an intervention. Okay. And the 3-year average after is showing to be around 2.8.
Okay.
So 3.5 minus 2.8 is 0.7. So there's been a reduction of around 0.7 divided by 3.5, that is 20%. There's a 20% reduction. But if I had taken this, which is 5, so 5 minus 2.8 is around 2.2. That becomes quite a large impact. Yeah. So what we are trying to say is that we'll only be looking at we should be trying to identify the true safety effect, and that is the fundamental first problem which we try to do when we are doing any kind of safety impact assessment is what is the true statistical measure of the difference. All right.
Yes.
Regression to the mean. So one of the things you'll find is that high crash locations are chosen for one reason, because the number of crashes are high, right? But the reason why they can be high is it could be just a random variation like what we observed here, right? Or is it truly high? Is the mean really high? And the second point is, even with no treatment, we could expect that the average could reduce. And the reason, and we will talk about this as we go through the lecture. The reason we can observe this is because let's say the ADT has dropped, the average daily traffic has reduced. Because of that, you might have a lower crash rate. So you have not done anything. So it has nothing to do with anything except that the ADT has reduced. And there are a lot of these other factors that might be influencing the likelihood of crashes. So we need to account for that. And we need to account for that properly in our statistical methods. So this gives a regression to mean. So this is just giving you the same example here, right? So you might have suddenly your crashes increase and the next year the crashes reduce. It has nothing to do with this thing. It's just a random variation. And why those random variations are quite high in percentages is also because the crash numbers are low, right? So if you have two crashes per year and they suddenly increase to 5, let's say here it was 1 and it increased to 5. Does that mean that the crashes have increased by 5%? No, it is just a random variation, and so not 5%, 5 times. So that's almost 500%. So it's just, you have to be very careful about that. So one of the first things which people tried to do was apply how do we solve this imprecision problem, right? So the first thing, because the data is a discrete data, you have number of crashes, right? Number of crashes per year. What you end up doing is you use something called a Poisson distribution, right? So basically, if you have 100 crashes per year on a 3-year data, the Poisson standard error is nothing but, so 100 divided by 3 is the is giving you the square root of 100 divided by 3 gives you the imprecision, plus minus 5.7. However, if there was one crash per 3 years and 3 years of data was used, what will that be? Or what will be the mean be? It ends up becoming quite high. So one of the things there are two problems with the Poisson distribution. First is that the mean is equal to the standard deviation, and we know that with crashes, the mean and standard deviations are different. And the future conditions are also not the same as identical to the past conditions. There's always some changes happening in our network. So that is where we ended up coming up with the idea of a Bayesian method. So what is a Bayesian method? What the Bayesian method says is that we need to be actually creating a something called a safety performance function, right? So what the safety performance function tells you is uh, for a given this thing. So this is before, right? This is before, and this is after. Sorry. Yeah, this is before and this is after. So one of the things which we want to be doing, and this would be probably the regression to the mean. So one of the things we want to be looking at is the first thing is when we decided, right, like when we looked at a before and after, what we might find is before we had say here this is around 13. So we had 13 crashes per year. That was the crash frequency, 13 crashes per year, and the ADT was only 10,000, right? It took us 1 year to 2 years to implement the intervention, whatever that intervention might be, right? We end up having a reduction to the same level, right? So we find that the crash rates are still around 13, but the ADT has increased to 2,000, 20,000. So when the observer kind of looks at it, when a decision maker looks at it, and they'll say that, oh, look, there has been no impact on crashes, but whatever was happening is now happening, and the investment we made was wrong. This is where the idea of Bayesian comes in. What you really need to do is actually look at this curve. This is called a safety performance function, and we'll discuss how it's built out. In that safety performance function, you find that for 20,000, the actual value is F2. And if you had done a linear extrapolation, it would have been F1. So you need to be actually comparing F2 to F3, not F1 to F3. If we do F1 to F3, we are overestimating. If we look at F3 only, then we are underestimating because we'll say that there's no impact. So it is basically F2. And we develop these safety performance functions. And this is where the crash modification factor comes in. So whatever this difference is, right, the difference has happened in this curve is because of the intervention, the crash modification factor of the intervention. Any questions?
No, sir.
Okay. Is this new? Have you all studied this before?
Not much, sir.
Okay. So I'm kind of. So this is what kind of moves to an empirical base. So that the idea is you're using an empirical Bayesian method. So you're not only accounting for what happened, but what has also happened, and given what is the current situation, what would be the expected number of crashes, and looking at that difference. All right. So I think we will walk through this. So how do we operationalize this? So how do we actually end up doing this? So we use something called a safety performance function. So safety performance function is going back to the example on the first day associated with, I think it was first day, where we were looking at the hilly roads, right? You were mentioning about hilly roads. How do we define the different sections? And one of the things about those sections are that these sections need to be uniform sections. They have to be uniform in terms of the number of lanes or some kind of geometry, the ADT. They're basically similar sections. So what you do is you actually regress the the crashes with respect to AADT and the road length. So it's the crash frequency is basically the number of crashes per kilometer per year, right? So, and you'll find different AADTs and you'll get different points on similar roads across across your region, and that will give me the the safety performance function. So I do a nonlinear regression, which is basically an exponential curve.
So sorry to interrupt you, but sir, is there any practical example which this safety performance for the road is applied in India?
Yes, yes, there are plenty of them. So the idea of there is, I think, there are a couple of papers that have come out of Trip where they've used the crash data to do that. Um, if you have the biggest problem is getting access to crash data, and I think there is a database now called RADS. Is that right? I don't know if Raghu is not. There's a crash database which is managed by the NHAI where you can actually
Yes, sir.
get some
NHS
of
is managing the crash database now.
yeah. So you can get a lot of those crash, and people have used that to estimate the safety performance function or the crash modification factor. So if you do a Google Scholar looking at crash modification factors in India, you will find at least, I think every year I'm seeing at least 4 papers come out in this area.
Sir, but the paper I read, sorry sir, but the database I read is not available to the public, but
I
is
know.
available to police department, transport department.
But if you have good access through the government and all of that, you might be able to get access to that data. So a lot of universities and research institutions are able to get access to that. The biggest problem in any of what we are trying to talk about is data. So even with eh, uh, the reason why the data is collected is for other reasons, and then what we are trying to do is to get access to that data, and it is never easy to get access to that data. So that's one piece. I would say that almost 60% of the effort goes into the data. Once you get the data, then everything else is much more simpler. And you have to then also modify your method based on the data which you have and is available to you.
Sir, the second problem here in India is to maintain the data.
But that's a problem everywhere, Manish. So it's not like, um, I mean, there are difficulties in here, but everywhere, even in the US, it's a problem. Even Australia, it's a problem. Access to data anywhere in the world is a problem, and that is something which I have learned. When I was in the US, I used to always complain, "Oh my God, data is not, it's such a big problem." Then I came to Australia, I was always complaining about data. Then I started working in India, and then there's one constancy. Data is getting the right kind of data you want is always hard, but you will get some data which, and you have to make the best of it. That's how you need to look at it.
While
Because
while reading one of the paper of Professor Geetam Tiwari ma'am of IIT Delhi,
yes,
sir, I came across through one statement that we can't rely the 5%. We can rely only 5% of Indian crash data. That's what.
yeah, okay, yeah. So I think that is a paper from 2013 or 15. It's an old paper.
Yes, sir. Yes, sir. Geetam Tiwari ma'am and Dinesh Mohan sir.
Yeah. So that must have been 2013, 15. It's an
Yes,
old
sir.
paper. I remember that. Um,
Yes.
so, but the quality of data has improved, to be honest. It is improving.
Sir,
That is,
actually, I am facing problem in my area to get the data. I got data, but not got sufficient data to do analysis. But I am But I am trying to get the data
So in
here
fact,
in Earth.
I will share you my own pain points, right? Like my own learnings. Um, so I've done a few projects in India, and the one time I actually decided that we should collect data, and that was around traffic data. And so it has been a mess getting traffic data, right? Like counts, it's a mess. You can't trust. Like I did not realize how bad it is. Like you really can't trust the count data you get um, from the count, like when counts are done and all of that. It is it is a really real problem. Um, right now, my conclusion is you're better off running an AI model to get your counts, queuing length, all of that, than actually getting a person to uh, do counting on data. So that's one thing. So that is my learning from, and how I would want to do things differently. To your point around what kind of data are you looking for first?
Actually, I sorted some crash data from Itanagar police station in Arunachal Pradesh, just like age, gender, what are the causes, what are the collision types, the vehicles, these datas which I sorted here. I got some datas from 2020 to 2024, but the main problem came here that they had not maintained datas from 2010 to 2020, but they are still trying to give me these datas. That's what I am facing here, sir.
So yeah, even like I'll tell you, when I was in Florida, when I was doing my PhD, right? Uh, when we were doing analysis on safety data, we were actually going through reports. They were like handwritten police reports. We were going through the handwritten police reports and actually coding it up. And this is probably what 2000. I mean, it is probably a long time ago, like it's 2010, 9, 10. So that's probably now what 15 years ago. Um, yeah, so it is, if you're trying to do safety studies in a new place, in a new area, when people have not even thought about the fact that you can do such analysis, there will be a lot of manual work. And try to figure out ways in which you can use uh, machine learning or even OCR, like character recognition, to actually pull out the data. You're better off. There will be there will be that you will need to spend 2 3 months trying to actually train those models. But once you do that, you might be able to get it to do better. And you also have then a solution which you can then take to other parts and get it and codify the data. But spend some time doing that. I think that is a worthwhile exercise to do. Rahul.
Okay, sir.
Sorry to
Okay, sir.
interrupt you.
Yeah, man.
Uh, Sir, but when we are saying that we need to pull out the data from AI ML and train the model, so the question arises here: how to validate those data, whether those are correct, whatever you are taking the
So
data from it.
you'll have to randomly validate it. That's what we have been doing. Like we still you have to randomly validate it.
Because
And
this is the question asked to me,
yeah,
and I wasn't able to answer the question because we don't have the proper data set, whatever available in the reports also. So we don't know whether those are correct or on what basis we are making the decisions.
so so let me go back uh, a step. There has to be a reason why you believe that the data is wrong. Let us not even go to the AI ML part. If there is a police report, so I'll give you one example of where I know the police reports tend to be wrong. One place where the police reports tend to be wrong is around the location. Like where did the accident happen? Right? Uh, the there is a lack of accuracy around that. Usually there is a lack of accuracy around that. It is a well-known problem. Okay, so now given that, how can you use this data set? One thing is, you know that it happened on that road. You might not need to know exactly where it happened, but you know that it happened on that road. So you can look at it as a uniform section and take bigger sections and do your analysis based on that.
Yes, sir.
So 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 this is where I think we need to be able to uh, uh, I absolutely empathize, and I know exactly what you're facing. One is, and this is where there's an art of articulation in this, is recognizing that, look, this is the quality of data. The quality of the data will enable us to do only this analysis and no more. And if we want to do this kind of analysis, we need that quality of data, which we need to train up the police and all of that. But there is still a lot you can learn. So it is a matter of getting your uh, uh, getting your expectations and training up your expectations and adapting your, the word is adapting your expectations based on the quality of data we have. And the problem you will find is, and me being an academic as well, so there's a bit of a self-criticism here, is you will also find that when we are, as academics, we like to be very precise and say that that is wrong, but there's nothing wrong about it. That's what is being presented to you. And as an engineer, if you're presented with lemons, you make lemon juice. So and lemon juice is quite useful, it's very tasty. So that is how I think we need to be approaching a lot of empirical analysis and empirical approaches. And modeling is exactly that. It is a recognition. The first piece is, if you have an opportunity to do the data, do it well. My learning from my own experiences, I would do things differently around data collection for traffic. I would actually perhaps go out and ask a lot more people about what have the problems they have faced around counts and all of that. That's number one. But number two is probably my first uh, my first approach would be taking a videographic machine learning model to count vehicles. But yeah, that's me. But I just wanted to share that I understand what you're saying, and I believe, like, if you're doing your PhD or you have a certain question, you're trying hard to find that particular data. But when that data is not available, recognizing that these are the limitations with it, but still you can find something useful, is a very useful task in itself.
Sir, can I like, I just have a doubt. If I'm doing like AI ML modeling and I'm getting the answers, so can I go reverse engineering? So what are the answer I'm getting? Like for example, 3. So I know 1 plus 2 is 3. So in the reverse manner, first I get the models done, and then to validate it, I'm doing that 1 plus 2 is 3 or 2 plus 1 is 3. Can
So
this be a method? Because I think this is a wrong actually, but still, if you want to do the validation, some method should be opted.
what you're kind of looking for is an automated validation method, right? So
Yeah.
there are two pieces onto that. One is that there is no way around actually doing a manual validation, right? And then, so a lot of machine learning models have a training method which is iterative. So what you do is, you do an estimation, and based on that estimation, you correct it and say that this is the place which you need to correct, and it retrain the model. Every time you're able to find an error, you retrain it. So, and then re-estimate and see whether you're able to get closer. There are going to be errors, but
Yeah, yeah,
so,
yeah.
so
Okay.
you need to be doing that. Now, I think we are still not there. There are explainable AI models where you can actually backtrack and figure out what the inputs are. and validate the inputs to that. But I don't think we are there. At least I'm not aware of tools which are reliable enough to do that well. The only thing which I know currently that I can do well, probably my understanding is a bit lagging. Probably it's lagging by a year and a half on this question you asked. But my understanding is we still do a lot of work by manually updating it and retraining the model.
Okay. Sir, many of the civil person who are working in the industry, like whenever we suggest a topic or when we say we are working on AI/ML modeling and also, so the question there is that we already had a good planning system already in the earlier India, if you see. So why there is a need to inculcate the your modeling system and everything? So you can go with the manual way, which were more concise and precise. Why there is a need to do AIML modeling?
So two things. First is question them on their assumptions about accuracy and preciseness, because um, it will fall apart there. I am almost 60% sure that it will fall apart there. The second one is cost. It will be cheaper. Manual methods are more expensive than
Yeah, I
uh,
agree.
so those are the two arguments. But I think start with cost, and if you want to be a little bit more confrontational, um, ask them about have they actually done an evaluation based on manual? Because there's again I'm telling you my own experience. I thought that manual would be more accurate, but the enumerators and all get so bored that the accuracies are poor, are really poor, and nobody ever checks it because there's this underlying assumption that just because it's been done manually, things are correct.
Okay, sir. Thank you.
So I'll continue with so I think I have a few more slides, and I want to finish the safety performance function. So if you can give me probably half an hour more, is that okay? Hello,
Yes, sir.
Raghu, is it okay if I take 15 minutes to half an hour more?
Yeah, 15 minutes fine, sir. I guess no issue.
Okay, I'll try to. So how are SPFs derived, right? So SPFs are developed using a negative binomial regression model. So you can actually look it up, negative binomial regression model. The reason why we use negative binomial regression model is the mean and the standard deviations are different in a negative binomial. If you do a Poisson distribution, the mean and the standard deviations are, the mean and the variance are the same. The mean and variance are the same, right? So SPFs are specific to a given reference group of site and severity level. So what we generally do is we create a safety performance function for fatal crashes. We create a safety performance function for injury, or we can just do it based on crashes, total crashes, right? So we have different SPFs. We also have different SPFs by different road types. National highways would have different, arterials would have different, urban roads would have different, intersections have a different SPF. Now, the second thing we always have is in a in a in a neg- in a negative binomial regression model, you have something called an over dispersion parameter. This over dispersion parameter is telling you how far away it is from the mean. So right, so it's basically given by sigma, and eta is basically the number of crashes per time, which is uh, which is giving you um, in a way it is the average crashes multiplied by the number of years multiplied by the number of the length of the road, and if it's intersections, it's only the number of years, right? So this is an example of an SPF. Okay, so I've written out. So this is a regression model based on a regression model for total crashes at a rural four-legged intersection, with a minor road stop control. So you have two roads, and the minor road has a stop sign. So the ADT is given. So you basically, in an intersection, your safety performance function depends on the ADTs of the two, and they have different factors, different contributory factors to the likelihood of crashes. So for ADT1, it is 0.65. So for the main, there's a higher likelihood. For the minor one, it's a lower likelihood, right? So for the same amount of ADT on the minor road, the number of crashes will be lower as compared to the main road, right? Because, and one way to think about it is because of the speeds. Now, if you remember, yes, again on the first class, we were talking about how when we define crashes, we are looking at what is the influence area of the intersection. Is it 250 feet here? Because it was in the US, we did this work. Is it 250 feet? Is it 100 feet, 100 meters, 500 meters? The way we generally end up coming to that number is doing a lot of model sensitivity analysis. So we start with 50 meters, 100 meters, 150, 200 meters, and we end up doing this. All right. Then we estimate the expected crash frequency. So we put a weight which is calculated from and I'll talk you through this. So this is the predicted accident frequency number, and then this is the observed accident frequency. So we can get the expected accident frequency. So I'll talk through. I'll give you an example of this. So the weights are given as 1 divided by 1 plus NP divided by sigma L, which is basically based on the predicted accident frequency. So let's say we have a certain ADT1 and ADT2. We put the values and we get the predicted number of accidents, right? The predicted number of accidents. Now, the predicted number of accidents is not the same as the expected number. Does that make sense? The reason is you have over dispersion, and you're trying to account for how many accidents have you observed. So you might have observed in that particular year, or in the last 3 years, you might have observed a certain accident frequency, but you need to correct it based on the predicted, and that's what the expected accident frequency is telling you. Does that make sense, what I'm talking about?
Yes.
Perfect. So this is giving you giving you a graphical representation of the empirical Bayes approach. So the reason why it's called empirical Bayes is because you are accounting for what is observed. So from your safety performance function, you predict a number, right? You observe something on the actual run. So what is your expected? You take a weighted average of that, which is based on this. And the reason behind it is you are what you're basically doing the weighting based on is the fact that there is over dispersion. There's over dispersion in your data. All right. Then you want to look at what is the expected number in the future, right? So the expected number in the future is the expected in the past multiplied by the predicted in the future divided by the predicted in the past. It's a very simple ratios. So what it's saying is that the ratio of the futures, the expected and the predicted, is the same as the expected and the past. So that's what you're doing. So the reason is you have this number from here, right? You have NE past from here, you have NP past from here, and you're going to calculate your NP future based on ADT. So you get ADT, you'll get your NP future, and you will get what your expected numbers are there in the future. So this ratio can reflect changes in traffic volume, countermeasures, etc. So, and that's where you have the idea of CMFs come in, crash modification factors. So now how do CMFs how can you use them? CMFs are expressed in terms of decimal factors. So CMF of 0.80 means there's a 20% reduction in crashes. A CMF of 1.20 means the crashes have increased by 20%. And how do I use this? So the moment I put a crash modification factor and I'm able to get the numbers, right? I get my expected numbers in the future. I can actually look at what is what is the statistical. I can multiply this number. Let's say this is about based on fatalities in the future. I multiply that with the value of statistical life, right? So there's I think IRC also provides some information on the value of statistical life. Raghu,
Yes, sir. We have some values, sir, actually.
Values. I think there is.
With respect to the wage rate of the people, so they are giving.
But is it from IRC or is it from another document? But there is some numbers which you can take, and that is how you actually get to the economic value. So this is how you would actually end up, how to use them. So I'm just going through this and I'll share this. So the expected crash frequency and CMFs can be multiplied together. So NE with is equal to NE without minus multiplied by CMF. So you just multiply the CMF and you get that. So the crash reduced is NE without minus NE with. That's it. And then you multiply this crash reduced with the value of statistical life or the value of losses, property losses, the value of injury, and you will get a total cost reduction, which you will get. So the CMF for a shoulder rumble strip, so there are rumble strips on shoulders, right, is known to be 0.79. So NE with minus NE without is equal is NE without multiplied by 0.79. So there's almost a 13% reduction, not 13, how much is this? 21% reduction in crashes. So this is giving you some CMFs based on different, it's called accident modification for different average annual daily traffic and different lane widths. As the lane widths reduce, the crash modification increases. So that means for narrower road, narrower lanes, there's almost a 50%. So by reducing my lane width by 3 feet, I end up with a 50% increase in the likelihood of crashes. That's how to read. That's how you would try to read this. And then you can multiply. So the nice thing about this whole approach is it's just a multiplicative of different CMFs. So you can do, say put a rumble strip, then increase the lane width. You do all of that and you end up with a different number. All right. So there are a lot of tools you can use. The best one is the highway safety manual. We need in fact, if any of you are doing research, we need a highway safety manual for India. If somebody can actually come up with a highway safety manual like you have an HCM for India, we need a highway safety manual for India. And there are other tools as well, like safety analysts and IHSD. Hopefully that. So with that, I can stop. That's all I had from this perspective. Any questions?
Sir, I request you, can you please share this slide with us?
Yes, of course, I'll do that. I've been doing that. I need to share the previous lecture slide as well. I'll do that.
Sir, we got previous lecture slides, but I think this slide is not there.
Yeah, I'll do that. I'll definitely do that. Any other questions? So the reason I put this together was because of the conversations we had on the first day, where you were also asking about how do we actually do economic impact analysis from a safety perspective. So I wanted to give you a flavor around how we end up doing it. And you can actually there are a lot of, based on, actually most of the pioneering work has been done by Geetam, Professor Geetam Tiwari and her group. I think there's also Rahul who's been doing some work there. Yeah, I think if you can put that all together, that like you can use that as an initial piece to do some analysis there. The other piece of research wise you can also do is using micro simulation using surrogate safety assessment. That is another way of actually evaluating that. But I'll send this. I'll send these 2 slides shortly. Any other questions, thoughts?
No, sir. Sir, one request to can you please share your email ID with us? So if I have any,
Yeah, sure. I'll put it in the list, of course. Yeah. I've been actually getting emails from some of you, so thank you for that. I'll put it in the link here. And please feel free. Usually it takes me a little bit of time to respond, so please be patient. But since you have my attention over the next few days, if you've got any questions, feel free to ask right now as well. But I'll definitely get back to you.
Yes, sir. Thank you.
All good then. Thank you.
Thank you, sir. Thank you so much.
Thank you, Raghu. Thank you so
So
much.
afternoon session, I will take that, sir.
Okay. Perfect. I'll give you a call after this just to kind of get.
Sure, sir. Thank you, sir.
Thank you,
We will
sir.
meet again at 2:30. Thank you all.
Thank you.